How we're going to look at systems of inequalities using one quadratic and one linear. So basically, we're going to solve by graphing, like you would normally. So the first thing we'll do is graph the quadratic boundary line. So that's where the quadratic would go. And just graphing that the same way you would normally. This one is a dashed line because it's just less than. So you find the vertex and then two symmetric points on either side, and there you go. You shade underneath because it's less than. Now we'll graph the line. So that's just y-intercept. Well, I guess converting it to slope-intercept form would make sense. So y-intercept at 4, slope of -4. You shade above because it's greater than. And the solution region is the part that's shaded by both. So the part that's surrounded by green, covered by the pink there. All right, that's it. So we're just going to graph. So let's take a look at the one we have to do here. So again, pause, and I'll come back. We'll compare. But yeah, you're just going to use this to do the graphing. All right, so the first thing I did was I took the quadratic function, figured out the vertex, was at -3, -21. Then the y-intercept's at -12. So I plotted the vertex, then just plotted the y-intercept at -12. It is dashed. The line, I put in slope-intercept form, got 3x plus 8, so y-intercept at 8. And then I'm sorry, it's it'd be +3. Shoot. So actually that line should be going. Oh, never mind. That's good. So that line's going up 3. So instead of going, so I went down 3 and left 1. So I did apply a positive slope there. I did make the line solid. And then I just chose the shading where it was below the blue and above the orange. All right. So it should be in between. Depending on how you zoomed, you might look a little different. I zoomed, I guess you could zoom out a little further, whatever. But that's what it should look like. All right, let's take a look at the last example.